Okay, so the first step we take in the process of network enumeration is identifying like hosts. So which are hosts that are live, right? These are some hosts that show us response to our activity, right? Or they show their attempts to hide this response, right? So this is important to understand in order to not miss a large part of the networks that are operated by relatively technically savvy network personnel. So there are people who obscure some hosts by different means. Everything you need to know right now is that not only the things are readily available and obvious to you are there might be some hosts that are actively hiding their location or their presence in the network. Okay, so how can we do that? First of all, there is this notion of common system administrating tools. Okay, so there are hacking tools that we use, right? That are specifically designed in order to perform this offensive type of security activities, right? But there are also very common and popular system administrating tools that can be used by us as well. Why not? So first of all, what is the simplest way to verify whether a specific host designated by a specific IP address is present in the network, right? So we can use ICMP protocol, right, in order to just send an echo request to it and receive an echo reply. So these two are different types of ICMP packets that are used in this protocol, right? So this is one example of using absolutely quote-unquote legitimate tools, right? Also, there is this telnet program that normally is used to connect to telnet services run on port TCP/24. However, it can be used in order to establish any TCP connection, really. So we can see that it can connect to any TCP open port or listening port on a host, and it may be not capable of doing all the application protocol stuff, right? So it will expect you to enter some protocol verbs yourself. However, in the terms of TCP handshake, so establishing a full connection to a service, it will serve you well. How can you use it? In two ways. First of all, you can just telnet to a specific host, right? To a specific port and wait for a while. If nothing happens, if it will just freeze in the console like that, it will most probably mean that after a few seconds, of course, it will most probably mean that it has successfully connected to the TCP socket, and yeah, that's it. So after some time out, most probably it will just break down, but in the meanwhile, you can use this other tool, netstat, in order to see what's the status of this connection. So you will see that connection is established, and if it's in established state for some time, that means that on the other side, the server has effectively responded to telnet attempts to establish TCP connection. So this is kind of useful in the situation you don't have any other parts of your toolkit with you, so you are on completely hostile PC that belongs to some system administrator and you don't have even nmap there. What is traceroute? Traceroute is a tool that lets you map network topology as a whole. So you are not expected to map a specific network you already are connected to by it. Okay, so it's rather a tool of establishing some knowledge about how different networks are interconnected, right? So for example, you are in a network, in a class C network of your own, it's your home router or something, and you want to understand how many different routers connect you to a specific network in the internet. Okay, so you use that tool in order to do that. You know the address that is out there, and you trace route there, and you see that different hops represent different gateways that you pass through on your route through this specific IP address. So how is it done? The techniques are quite tricky, so it employs both ICMP and TCP/UDP levels, right, of TCP/IP stack. So what you should know in order to understand how it operates is that every time you're trying to establish a specific TCP connection, for example, right, the router that is supposed to be the last, in this chain of IP gateways that connect you to your target, in case the port is closed on the target machine, it will be the gateway. I mean, it will be the source of a response issued to you. That there is no open port that you have specified in your connection parameters. So traceroute gets it takes advantage of this functionality of this particular situation in the protocol interoperation, right? So it is trying to understand what's going on the network by subsequently issuing the requests of different TTLs, of different time to live parameters, starting from 1, for example, and if you run it, you will see interactively that the first hop that appears, the first gateway, is your own. So TTL1 resulted in that the first gateway just got your packet and decreased its TTL value, and see that it's already 0, and it's just calling you back saying, I'm not sending that anywhere. So here you are with your receipt of not transmitting your packet anywhere else. So repeating this in order by increasing every time this TTL parameter on your side by 1, you will receive a pretty correct representation of what is the portion of the network that connects you and your target. So this is somehow related to penetration testing activities. Unfortunately, EC Council thinks that you have to understand how it works, and if you want more detail in this operation, please take, for example, Wireshark and see what activity traceroute generates when you run it. The other part of common system administrating tools that can give you an advantage on a penetration test are these Windows-related utilities. For example, NBT scan just gives you an idea of what's going on in the Windows world in your network. Of course, everything will be to the most extent limited to your own physically connected segment, like Class C network or VLAN that you are connected to physically. But still, it's a lot of information of what's going on, who is performing what role, and what are the shares, and maybe even what are the user sessions, if Windows is configured not very securely, right? And the second one is ShareInam. It's of course a part of Mark Rusinovich's SysInternals suite, right? So you can download it from Microsoft, and it's really cool. So it just gives you a really thorough representation of what file shares are published on the network, and what information then they contain, and which of them you can access with your current permissions. And it's a very cool auditor's tool that allows you to see who is sharing what, and if some of this stuff is classified and it's anyway shared even internally, that will give you a reason to start an internal investigation, for example.